Okay, we are going to make one more attempt at this. This is like the 7th time I've done this. Okay, I have sound now. I can see the video. I can see the slideshow. And I am hoping that all of you can see the same thing I'm seeing. Please leave me a note if you cannot, and I'm going to do this again like you can see everything I am seeing. I apologize for all of the technical difficulties. I'm hoping that at this point we have worked all of those out, and that by this time, chapter 4, because we are on chapter 4, woohoo, we're on chapter 4, we're halfway through, that we've done away with all of the technical difficulties. Now, we have a couple of people who will be joining us a little bit late into this activity, and please reassure them when you see those new names come up that this is not one of those classes where it's so stringent that nothing, is everything is on a timeline and it has to, it's not. It is not one of those classes. You get to do this on your time when it is right for you, and hopefully you guys are getting something out of this course. That is my main goal. And with all professional development, if you walk out with one thing that you can use in your classroom and can make a difference for your kids, then you've accomplished something from that. Chapter 4 is when we're adding 10. But before we get into chapter 4, there's a couple of things I want to really pay attention to. The precision in the language that we are using towards our kids, and we are making sure our kids are giving back to us. I'm going to really beat this dead horse, because it is so important that we are making a difference in distinction between numbers and digits, because digits and numbers are not exactly the same thing. A digit is a symbol that represents the value of the place that it holds. So when we're discussing digits, and we can do this all the way down in kindergarten, when we're discussing this number, all right, this digit, I gotta go backwards. This digit is the digit 5. This digit is the digit 1, but this number is the number 10. And that's what we're going to be talking about during this chapter, because it gets so confusing when we call this a 1. It's not a 1. It's the digit 1, but the value of this digit is 10, which makes it the number 10. And if we can really get ourselves to talk about the numbers that way, so then if we do add another digit to this, we have now changed the value of this number just by adding another digit. Now we added the digit to the ones place, so that is the digit 0, but it has a value of 0. That's the digit 5, but the value of that digit is 50. That's the digit 1, but the value of that digit is 100. And that can be a huge mind shift if that is not how you have been using mathematical language in your classroom. So that is something definitely to think about. And if you haven't and you want to have that discussion with me, I am more than happy to have that. That may be an email discussion you want to have with me. So if you want to, you can definitely email me about that. But that's one of those things I want you to really pay attention to. Here's the other one. I noticed that some people, I made sure I had lots of paper available, I noticed that some people were discussing, and this is something really to think about, especially in those lower grades, because they're going to carry this through the rest of their school time. In those, when we're talking about numbers, and we're talking about numbers being bigger and smaller, if a 5, if we say a 5 is bigger than 4, then we need to make sure a 5 is really bigger than 4, because this time it is. If we actually talk in precision about these two digits, the 5 has a larger value than 4. If we truly start talking about the value of numbers, and we say the 4 has a larger value than 3, then it doesn't matter if the 3 is actually in size larger. And that does carry all the way to 5th grade, 6th grade, 7th grade, 12th grade, college, when they're talking about the values in numbers. Because when we say that this is bigger than that, that needs to be the language we speak of in geometry, not in numeration and number sense. I hope that makes sense. Talk to me about it if it doesn't, because I would definitely want to make sure that that is very, very clear when we're talking about it. Okay, so chapter 4. Chapter 4. I like this one, and it has a lot of activities in it. So in chapter 4, the homework, I'm going to give it to you straight up front. Okay, the homework has lots of activities in it, and you get to choose 2 activities from this chapter to do with your class or with the kids you tutor, or however you choose to do. You get to choose any two activities and do them, and then post how it worked out in your classroom and talk about how you heard the language in your classroom. That language piece is so incredibly important. So I want to definitely hear about that. Your posts have been fantastic. I absolutely love hearing about how the kids are talking, and when you get that, well, I thought this was going to be easy, but it wasn't for my kids. I love hearing about that and what you're doing with that. So that is fantastic, and I hope you're getting something from each other's posts as well. Okay, so adding 10. By focusing on math facts with simple add-ins 0, 1, and 2, the students now have 57 math facts. So if they have mastered 0, 1, and 2, they have 57 math facts. And all the unknown facts are more complex, and the students have a sense of accomplishment at this point. That is something that we definitely need to celebrate, because that is fantastic. The next focus on the facts will help build a strong foundation, and then the facts with 10 as that next add-in. And remember, at the beginning I said that we were going to talk about 10 being one of the facts that we were going to talk about. Focusing on plus 10 thinking is an investment in efficiency for the future, because once they get that, it can make 10 and that 10 base thought process, math becomes automatic. It's that automaticity fact, it's that fluency fact, it gets everything else where the train definitely connects. It is a wonderful tool for them to have in their tool belt, and the strategies that they can actually use with it are like infinite, because everybody will use them a little bit of a different way. Now, the big ideas we're going to focus on this time are that numbers can represent separate objects in groups or in groups of 10. Adding 10 to a single digit number will add 1 place value, and the order of add-ins does not change the sum. I wonder if we've seen commutative property before, or if we'll see that again. Now, the first one we were talking about. Objects can be counted separately or in groups of 10. Now, when we're talking about our objects being counted separately, of course we can have them like this, or we can have them like this. Our students begin to understand what a 2-digit number represents as we, begin with the 5 objects. So we begin with 5 objects, and then when we add that 10 more, where'd my 10 go? We add 10 more so that, and I had 10, there we go. And then we have 5 objects, and then we add 10 more to it, and how many do we have? We have 15. So now we know that we have 15 objects. This is not an easy primary concept. This really is a very difficult concept, and especially when it's in a scattered array like this. When this type of thought process is what's used all the time, number one, their one-to-one correspondence in kindergarten, not always great. Number two, when it's in a scattered process like this, they don't have that organizational view of it. That's where subitization comes in so very important, because when you subitize right away, you can see that this is 5. It's much harder to see. I am so bad with which way to go with the camera. It's much harder to see that this is, when you subitize, that this is 10. Okay, adding 10 to any single digit number will result in a 2-digit number with 1 in the tens place. That's what we were talking about when we said that, just because you put that 10 there doesn't mean there's a solid understanding that that is a 10. And if we continuously call it a 1, that's incredibly confusing for our Wonder Nuggets. So we would need to make sure that every time we put it on there, when we have that by itself, yes, we can say 1. But when we add anything to it, we need to make sure we're not saying, we're not saying 1 and 5 are 15. No, we need to say the digit 1 with the digit 5 is the number 15, because this is the number 15. The digits 1 and 5 together make the number 15. I hope that makes sense. Okay, and again with the commutative property, the order in which you do C, whether you're 5 plus 10 or 10 plus 5, absolutely does not make a difference, in the sum. And for our younger kids, that does mess them up because it's not the same thing to them. Whatever they see first, they have that left to right orientation. This is not the same problem to them. So that's something that definitely needs to be looked at, for them. Now, I would love to know if you guys have issues with your kids with the commutative property, because when you put that left to right orientation and then you put that equal sign, if you turn that around and you put the equal sign first, a lot of the kids are going to tell you right away, that's wrong. You can't do that. That's not a rule you can do. And we need to expose them to having that equal sign on the left side and working with the answer from the left and moving right. Now here's some questions that you can ask. This is not what Chapter 4's homework is about, but when you add 10 to a 1 digit, how does it change the number? And the answers that you get are really important here, because if they don't say something to the effect of, how does it change the number? It increases the value by 10, or it makes the number's value increase. It doesn't make it bigger. It doesn't. Okay, why is the sum a 2-digit number? Because there's a 10 in that number. That would be one of the things you really have to, make sure they understand. How could you quickly find the sum of a number plus 10? That's a really good question to ask your kids, because then they know it's 10 and whatever that other number is. And when you do that quickly, they get that automaticity and they get that fluency, and it works. So look through these questions and see if there's some you want to focus on. But make sure when you're asking these questions, like on that last one, this one down here, that you're asking, from the number 11 to the number 19. That, because otherwise you're going to mess them up. Okay, our literature link is a book that I absolutely love. Laura Numeroff is one of my favorite authors. If you give a mouse a cookie. And I'm not going to read this slide to you because you know how to read, and reading slides is just not fun in any professional development whatsoever. I have the before reading, during reading, and the after reading, and if the book is at your school, this book, the Basic Math Facts book, is at your school, then you can go in and get that and read that section, and it has your literature links on what to do before reading, what to do during reading, and then the activities before, during, and after. And then it has activities for you to do and different things that, what you want. Now, I did try very hard to make the PowerPoint as fact-filled as I could, so that if you couldn't see the video, then you could look at the PowerPoint and make sure you could go by the PowerPoint alone to get information. One of the things to make sure, and this is the only thing I'm going to point out with the literature link, the first time reading this, you kind of don't want to have a lot of conversation, because I know everybody's read Laura Numeroff. There is no doubt about that. But you don't want to have a lot of conversation because of all of the events that happen in her books. And when you stop and have a lot of conversation, the story gets lost. So you would definitely want to just keep the story going, and then wait to have the conversations about, well, what will happen next, and what do you think will happen next, and what do you think the mouse is going to do next, and what do you think is going to, all those kind of conversations for later. And then you can see here what the before, during, and after is. And I'm going to post the PowerPoint separate from the video, so that if you want to go back and refer to it for any reason, you can. And the activities that we're going to look at, I'm going to post all of the worksheets in Edmodo, so you'll be able to pull from there. The CD that you have in your book, you should be able to pull from there. Everything that we do on here is on that CD. And I believe, Michael and I believe, everybody should be able to log into that CD, but I need you to let me know if you can't. Okay, so Michael and I can work something out if everybody can't log on to the CD. But I will download all of the papers I show you today. I will log on to, or I'll download to Edmodo in our library. Okay, now some activities that you can do. Students select a cookie card, and they will be adding 10 chips to the cookie. So this one is a lot of fun, because you can use, 10, I'm trying. Nope. Come on now. Yay! It's the cookie template. Okay, so with this one, you'll cut the cookies out, and they each have a different amount of cookies on them. And each one of these, you can use real cookies, you can use dots in your classroom, you can use whatever you want, but you'll pass out the cookies to each of the kids, and then they'll add 10 more to each of these. So, like for instance, on this one, we would have to add 10 more. So we would 1, 2, not like you don't know what 10 more is, but okay, so we have 10 more on here. Then we would use I apologize. It's not letting me out. Hang on a second.